In this video we will be disproving the claims of a flat earther by conducting an experiment on the limits of human color perception, so stay tuned! Hello everyone and welcome to this somewhat special video because this is actually the first experiment that I have ever done in the confines of this YouTube channel and for the explicit purposes of disproving a flat earther's claims that have been directly made towards me. Now here you can see 3 LEDs that are on my desk. You may wonder why I have 3 LEDs on my desk. This is because Kryptonite Physics, or Chris UK as he was formerly known, has challenged me to do an experiment with LEDs to see whether or not his number of 0.01 lux for human color perception can actually be correct. Now, I'm not sure why he isn't just doing it himself, but here we are. These are some LEDs from my electronics cupboard, and I have managed miraculously, the chance of that I believe was very, very slim, to find the exact specifications of these LEDs, because as it turns out, these 3 LEDs are Everlight LEDs. Here is the red one, just in comparison. Although they noted that the pictures might be slightly different from what is in the manual to what they actually ship out. As we can see here, there are a whole bunch of parameters. Now, please note, I will operate it in the operating temperature. It will reach, I will be doing this in the evening at the place where I volunteer. In the evening, we will get around -3 to -4 degrees Celsius. So this is perfectly within the operating temperature. And here, and this is the most important part, we have the luminous intensity given as typically 160 microcandelas, so 0.16 candela, under typical conditions of 20 microamperes. And the measurement uncertainty of luminous intensity is ±10%, so I'm giving Chris the benefit of the doubt here. And every single time I will be doing calculations, they follow in the next segment of this video, I will be adding, pardon me, I will be adding the uncertainty to the existing value and then round up. So I will be very, very gracious, because I would like to use the worst case numbers for my case. My case being that we can see way beyond 0.01 lux if it is a point source, which an LED for all practical purposes will be. Now here you can see for the red LED we have 160 microcandelas, and below here there are the graphs of how big the LED is supposed to be. And you can see here it's supposed to be 6, including this little socket here, 6 millimeters in diameter. Only the LED part without this little socket down here should be 5. It should be 8.6 millimeters high, and the cathode here, the other one is the anode, the cathode here should be in the range of 16 millimeters minimum. Now I have measured all of these out, of course. Here are those are the green ones, I apologize. Here is the red one. So here, unfortunately, the image here isn't precisely sharp, but I've measured the diameter of only the head, not including the socket, with my calipers, and they came out to be 4.9 millimeters, which is within the tolerance of the given data here, plus minus 0.2. I've also measured the thickness of one of the legs, which are supposed to be 0.5. They are more to like 0.46 in this specific case. And I've also measured the height, which came out to be 8.5, which I had rather 8.6 plus minus 0.3 are supposed to be the right ones. Now, this is, of course, isn't perfect. This is just to show that I didn't make a grave mistake by selecting the LED, because at first I was looking at an LED that was only 3 millimeters in diameter, and of course, this would be the wrong one. I did all this for the other LEDs too. The yellow LED, from the picture right here, yellow LED. The yellow LED has very similar operating temperatures. It is brighter than the others, and just from looking at it, when it is on, I would agree with this assessment. It is the brighter of the three. At 0.32 candela, again, rounding up, adding the uncertainty, I will be calculating with 400. The yellow LED I've measured here. I've on purpose not photographed this from the very top so that you can see that this is actually the LED and not something else. Again, here, 4.9. We have 8.57, and again, 0.46. And the same thing I did with the green one, green LED right here. Again, similar operating procedure, and it is the dimmest one. Also, this roughly fits with what it looks like to the eye, but I will be calculating with 0.1 candela. The first one I've not mentioned, I will be calculating with, I believe, 0.2. And the measurements for all of these are the same. They're just slightly different versions of this data sheet. This one doesn't have any red lines. These ones have, and in this one, for some reason, the picture is larger than with the others. Exactly. And I've also measured the green LED here at 4.9 in diameter, at 0.45 in terms of leg thickness, and here again 8.56. And the problem here, you can already kind of see this here. The plastic at the bottom of this of the cap of the LED isn't exactly even. You can see this here because here there's a little piece of plastic overhang. So this is not a particularly precise measurement, but it is well within the uncertainties of what is listed on the website of the manufacturer. All right, now that we have sorted this one out and it is established that these are, in fact, can reasonably be assumed to be the LEDs in question, I would like to briefly go through the expectations that we have with this specific experiment. All right, so let's now turn our attention to what we would expect. So first of all, from the data sheets, we enter here the luminous intensity in candela. Now, as I said here, I added the plus 10% here for the measurement error, and then I rounded up to give the most pessimistic case, or in this case, kind of the easiest to test, if you will. If we do that, we get this many candela. The red one for 0.1, the yellow one 0.4, and the green one 0.2 candela. Now, what are Chris's claims? It gets here from Chris's prediction, in this case from this comment here. He says 0.01 lux is the absolute and definite limit to seeing color. And then here he lists the one for, or the ones for the respective colors. So from that, we can calculate a distance at which you should see it. So you take the luminous intensity and the luminosity or luminous flux, you divide them according to the formula here. This is the formula of how candela and lux relate, by the way. And then you get the R after pulling the square root. And from this here, you can see that Chris's distance for seeing the color of this specific red LED is 1.6 meters. And at 2 meters, you would already not see it anymore. Needless to say that this is obviously ridiculous. My estimate here gets a little bit more complicated. So first of all, we have to do a whole bunch of assumptions. First of all, I assume monochromatic light, which is not correct, but it is within the vicinity. I say the light is mainly distributed over 30-degree angle. This is also supported by what it says in the data sheets, that the light cone is about 60 degrees in diameter. I say here that over the short distances that I'm measuring, I have already checked the largest distance that I will be measuring is roughly 85 meters. So I say that over this distance there will be no significant extinction in the atmosphere. I also assume point sources so that they are smaller than or equal to 1.1 to 2 arc minutes, which is the smallest thing we can see. Anything smaller will appear that size anyway. I also assume that we need 50,000 photons in total to see color, as I explained in the earlier part of this video. I also assume that my eyes are reasonably good, so that I don't have significantly bad eyes. We also assume a fair observer, that is me not lying about when I see color and when I don't. The nice thing here is that my fairness can be tested directly if you repeat this experiment. And I also assume a 30% efficiency from turning the energy or the power that it receives from the battery into light, which is actually, I have read, not unrealistic, although most LEDs are more closely to the 40 to 50% range, but regardless. Okay, so what do I expect? This calculation is somewhat complicated. So first, we know, I assume we need 5 times 10 to the 4 photons per 0.1 seconds roughly to see light. So I estimate here 500,000 photons per second just to be extra sure. I think we could see less actually. At the size of our pupil, which I calculated to be 38 square millimeters, we need 1.3 times 10 to the 10 photons per square meter and second. Then I take gamma. I define this gamma as the number of photons that the source emits per second. Gamma here, by the way, can be expressed as the power divided by the energy one photon will have on average, based on the dominant wavelength from the datasheet and the power from the datasheet. And from that, we can equate this. And here I have the only 60-degree field of view, kind of, and not the whole not the whole sphere. And from that I get an R that is roughly that, and if we put the numbers in, I get a yield of roughly 1.5 kilometers for the typical values. Now, is this a problem? Let's have a look at our assumptions. Yes, it is, mostly because at 1.5 kilometers extinction would play a role. So I can't, or not with the experiment I have in mind, not with the material I've prepared, test my claim to this extent. However, I can still make an effort of disproving Chris's claims rather easily. So this is a problem. I may repeat this at some point, but my estimate, just for our testing purposes, the longest distance that I test is 85 meters. So I just say that at 85 meters, I should be seeing the color or recognizing the color easily. So I say more than 100 meters. All right, let's talk about the experiment itself. First of all, the distance that you will see in the video, the first distance, I call it the border or the corner of the building. That is at 45 meters. This is right here. This is where my car is parked. And then I walk all this way up here. This is the corner of the building. And then I walk up until the road. And this is here. This is 58 meters. Let's make it 55 for the purposes of this video. And the long distance at the end, where I will only test one LED out of curiosity, is 58 meters. It says 85 meters. It says 87 here, but I didn't go all the way through there. All right, so with that, now I will turn you over to the reporter in the field, which also happens to be Olaf. Well, let's have a look. All right, so here I am now in the garage of the place where I volunteer, and here we have the extremely highly sophisticated circuit of an LED and a roughly 2-point-something volt battery, and the overall idea is that I fix this extremely highly sophisticated circuitry someplace outside, and I will see how far I can see it. I will do this with all three of the LEDs, all three of them, so green, yellow and red. Alright, so here I am at my car, and here you can see, or cannot see, the highly sophisticated circuit fixed with a piece of sticky tape to my car, somewhat poorly. And I will now, I hope I have orientated this roughly correct, I will now walk over there, and we'll see how far I can see it. Now, if the predictions are correct that I made, I should be easily seeing this color. If Chris's predictions should turn out to be true, then I should already now, I've gone farther now than 6 or 7 meters. By now I should already not be able to see it anymore in color. Let us turn around very quickly. It is blatantly, clearly red to the eye. Maybe not to the camera. I think it is though. So let's walk back. I need to blur my license plate now. I have forgotten about that. I will probably edit this somehow. So I've now reached the border of the building where I volunteer at. You can not see the border. You can see it now. There it is, a border. And according to Google Maps, this is roughly 43 meters, and I can easily see this as red. I could walk even further. I will now go into public land. I am dressed in reflective clothing, so I should be fine. Just letting this car pass, and I can clearly still see it as a red light there. Alright, I've reached my car here back again. I will exchange the red LED for the yellow one. You cannot properly see it. Here it is, the yellow one. Just 1 second. Oh, we have a solid connection now. It is yellow now. Now I'm just filming this walking back here, just so that no one in the end can say that I didn't walk back or that I did something wrong. Now I generally don't think that Chris would be this kind of person. This is a somewhat common behavior among flat earthers, that they say that, well, if the outcome doesn't fit their prediction, then clearly my measurement must have been disingenuous. So now standing here at the edge again. Here it is, the edge, and I can clearly identify this as a yellow dot. I don't know if you can. I certainly can. All right, let's get back a little further, by about 5 meters or so, onto the edge of the property, and it is still clearly identifiable as yellow. Again, unsurprisingly, showing kryptonite physics' prediction to be false. Unsurprisingly, as I've pointed out multiple times, because you do not need to see with every cone in order to have an understanding of the color that you see. And as a matter of fact, if you would see with all of the cones, it would just be one solid amongst your whole field of vision light. Now for the last of the lights, we have this yellow one here. We'll exchange it now. There we go. For the green one, I hope this is somewhat visible. Yes, clearly the green one. Can I do this with one hand? And the masses are ecstatic. I managed to change it with one hand. Very green on camera, not as blatantly green in real life. I believe this should be more or less fine. Certainly within 30 degrees of where I'm going. And I'm going back now for the last time. Again, according to Google Maps, this is around somewhere in the area of 35 to, I believe, 45 meters. I will need to check exactly from where my car is parked now to the precise position there. Exciting stuff, I know. Certainly record-breaking science is done here tonight. There's the edge again. And so here I am. Now this is clearly green or yellowish, but I must admit that it is less clear with the eye than with the camera at this distance. But it is clearly not a neutral bright light. It is definitely not white. I would say it is either yellow or green, but the longer I look at it, the more confident I am that it is in fact green. I'll now go to the border of the property, and here again it is clearly green. So all three of these tests show, in my mind, conclusively that kryptonite physics' predictions are falsified. I might tomorrow, or might actually, no, why not do it today? I can find another spot to test this at that is around 60 meters. So stay with me. Alright, I've now added my fingerless gloves to my equipment, as we have around -4, I believe, or -5 degrees Celsius. So whilst it's not extremely cold, it is rather frosty. So I'll now fix the LED light to the garage door, and I will walk down the street as far as I can go without violating my emergency readiness time. All right. All right, the highly sophisticated circuit is fixed now to the little box that checks your card to open the garage, and I will now walk down this street here. And I encourage you to briefly hang on here now. The thing that gets me about this whole discussion, and I have to speak a few words of encouragement here actually towards Chris, is that I believe, to the best of my understanding, that Chris is the first flat earther that certainly I've encountered that is not either blatantly misrepresenting an existing experiment, or that is just basing his argument off of a severe lack of understanding, as some others do. I still obviously believe that he's very wrong, but no less the effort he puts into it, and actually citing papers and doing the maths to what I can from what I can tell accurately, or at least sufficiently accurately, is commendable. And this is obviously red. It is right there. I think you can see it on camera. This is obviously like really a bright red to the naked eye, a lot more so than to my phone's camera here. My phone, by the way, in case you're wondering for research purposes, is the OnePlus, I believe, 7 Pro or 7T or something like that. Yeah, so again, and according to Google Maps, these are what just from sight, I would estimate this to be 70 meters, 80 probably, possibly, but yeah, so I believe with this, the experiment section of this discussion is concluded, and yeah, I will gladly put this now to tomorrow, Olaf, to give you the conclusions and the exact figures and maybe a more nuanced voiceover. All right, thank you very much yesterday evening, Olaf. And with that, we have the results right here. All three lights I have been clearly able to distinguish from 55 meters. And the red light, which is the only one I have tested at 85 meters because it went rather cold and I wasn't particularly motivated to do the other two, because I am very confident I would have been able to see the color thereof. So the red one, which should have had the shortest distance, with Chris's calculated distance of only 1.6 meters, was clearly visible at 85 meters. I have no doubt that I would have seen it like that at 100 meters or more. Now that leaves, unfortunately, Chris's claim, Chris's calculation can be dismissed. It can be ruled out. With that, Chris's claim of the lux can also be ruled out, because this is where they come from. And my estimate of 100 meters, or of above 100 meters, is still valid. Now, my particular estimate of 1.5 kilometers probably is invalid insofar as that I didn't take any atmospheric extinction into account, which needs to happen when we're talking about distances and these kinds of distances and these low level luminosity. Exactly. So, little bit of self-criticism. What I really wanted to do was a blind test. Unfortunately, I think I need two people for a blind test, one of which picks the colors and the other one, standing at a distance, tells the which colors they see. So I picked all of the colors and when they were shown, so you need to believe me that I was genuine in my assessment, and I highly encourage you to redo this experiment with LEDs of known luminosity and do similar calculations that I do. I'm also not 100% sure if I understood Chris's predictions correctly. From the comments, they would seem rather clear, but I of course I don't want to be take anything that I misunderstood and run with it. So Chris, if these weren't your predictions, I would be happy to work with your updated or with your actual predictions, but from what I understand, you say that 0.01 lux is the absolute limit to color perception, which I have now clearly shown to not be the case. Um, so, what did we do? Well, we did science. I'm sorry, this shouldn't be here already. I forgot to blend that in, but I'm not going to change it anymore. So, or we did the weirdly strict flat Earth version, anyways. So we made a prediction, we made a hypothesis, and we made an observation, we made a hypothesis, and now both Chris indirectly and me made a prediction, and I conducted the experiment, and well, my hypothesis still stands, but well, so we both did the first three steps. I did the experiment. Now Chris has, I believe, in his comments said that he also did the experiment, but he doesn't have a video of it, so there's no real. How would I know? And he in from what I can tell from the comments, he insisted on using a light meter that is not going to pick up luminosities as tiny as the one emitted from a 60 milliwatt LED over over multiple meters distance. I have severe problems believing that light meters exist that could measure that aren't specifically astronomical equipment. Yeah, so with that, Chris, I genuinely think you need to revise your hypothesis. From what I can say here, and assuming, of course, that I understood you correctly, I have shown your hypothesis or your prediction to be wrong. And I think you very much need to revise your model and revise your opinions on the way we see color. Also, I would encourage you to redo the experiment in a similar way that I do, maybe with a second person just to do a blind test. Yeah, exactly. And upload a video of it or document it in another way that you see fit. Yeah, the outlook here is that I certainly want to do a color recognition test of more than 100 meters. I have a spot in mind that, according to Google Maps, when I briefly checked, is roughly about 500 meters, 560 to be a little more precise. That I might do when I have someone who agrees to do this with me, because this would, of course, take an hour, maybe. Or a little longer. I would do this with a friend, which would also allow for blind tests, where I would essentially tell them that they could pick any of the colors. I would also like to include blue next time, but my blue LED is somewhat shoddy, or the blue LEDs I have are really shoddy, so I kind of didn't want to use them. I may get some other ones until then. Either way, I would like to repeat this and allowing for blind tests where the other person can pick one of four colors and white, and I could tell them, or I could record which colors they were, and then we could compare which colors they put up and which colors I identified to really show whether or not this is what they did. Yeah, so with that, I think this video has come to a nice conclusion, and so, at least in my mind, has this discussion. I've thoroughly proved Chris's claims here wrong, and I would highly encourage Chris to revise his ideas about how we perceive color and what the actual limits are and why they are the way that they are, with some of the resources that I have brought forth and shown him. Yeah, either way, thank you very much for watching. If you enjoyed this experiment and you would like to see me do more of them, maybe, I don't know, maybe consider leaving a like, and if you enjoyed a lot, maybe considering subscribing, and I will see you in the next video and or live stream. Essentially, my cough has been getting better. There may be one of them again. Yeah, so I hope you have a nice time until the next time. Goodbye!